Alright, today we're looking at lesson 5-2, prime factorization, on page 124. You may have done this last year in class, so this might come back to you hopefully. But to do prime factorization, you have to know your prime numbers, or what a prime number is. So let's look at this first. How can you write the prime factorization of a number? Right, that's what we will be doing today. So whole numbers greater than 1 are either prime or composite numbers. Notice that they say greater than 1. 1 is considered neither prime nor composite. So we're looking at numbers greater than 1. So don't remember that 1 is neither prime nor composite. A prime number has exactly two factors, 1 and itself. So they tell you the numbers 2, 3, and 5 are prime numbers. So you want to write those down. Write these numbers down at the top of your page. 2, 3, 5, 7, 11, 13, 17, and 19. The first, through 20 anyway, the first 8 prime numbers. And you'll get a list tomorrow when we work together. But so a prime number has exactly two factors, one in itself. That's the only way you can get that number. So they show you in these models over here. For example, 2. So see, they have 2 blocks there. The only way we can get the product 2 is by multiplying 1 and 2 together. Two factors, 1 and 2. The number 3, see the 3 blocks? The only way we can get 3 is by multiplying 1 and 3. See the pattern here of prime numbers. 1 and itself. 1 times 3 gives you 3, so 2 factors. Now this is 4. We have 4 blocks, and 4 is different. We can get 4 by multiplying 1 times 4 or 2 times 2. So 4 has 3 factors here, 1, 4, and 2. So 4 would be a composite number, not prime. 5, the only way we can get 5 is by the factors 1 and 5. 1 times 5 gives you 5, so it has only 2 factors. So that's why they are prime numbers. And I'll give you more again. So 2, 3, 5, 7, 11, 13, 17, and 19 are all prime numbers. Alright, looking on page 125, they have composite numbers. A composite number has more than 2 factors. Okay? And we could write a composite number as the product of its prime factors. This is called prime factorization. So this is what you're going to be doing today. You're going to find the prime factors of a composite number, and we're going to write that down, and that's called prime factorization. So for example, 4 that we just looked at over to the left is a composite number, and the factors of 4 are 1, 2, and 4. Now, of 1, 2, and 4, the only prime number is 2. So 2 is its only prime number, or prime factor, I'm sorry. So the prime factorization of 4 would be 2 times 2, or remember that we could also write that as 2 squared. Okay, so to find the prime factorization, hold on. Okay, so to find the prime factorization of 60, they have us write its factor, beginning with the smallest prime factor. So 60 would equal 2 times 30. So we keep the 2 because 2 is prime, and they bring that 2 right down here, and then they break up 30 into its factors. Well, what are a couple factors of 30? Well, 2 times 15 would get you 30. Again, 2 is prime. And then we have 15, which is a composite number. So then we have to break 15 down. We still keep the first and second 2 that we had, break down 15 into 2 factors. Well, 3 times 5 will get you 15, which are prime numbers. So we're here. We have our prime factorization. We can write the prime factorization of 60 is 2 times 2 times 3 times 5, or use the exponents. Remember, 2 times 2 is the same as 2 squared, or 2 to the second power, times the 3 times the 5. So this is another way to write the prime factorization of 60. Let's look at some more examples on page 124. Okay, we're looking at another example. How can you use a factor tree to find the prime factorization of a number? This is a little bit easier to visualize. So we're looking at one way to find the prime factorization of the number 72. And this way they say, well, go ahead and begin with the smallest prime factor, and then write all the factors until all the factors are prime. So we start with 72 here at the top, and they break off and they find two factors of 72. We know it's even. Notice we're using these divisibility rules from the previous lesson. There's a 2 in the ones place here, so I know 72 is divisible by 2, so I can say 2 times 36 will give me 72. So I branch off to the 2 and I branch off to the 36. And I'm going to circle this 2 because it's prime and not even worry about bringing it down. I'm going to circle that. That means I can stop there. So 36 is not a prime number. So that means we need to keep on going. So think again, smallest factor of 36. Well, we know it's even because the ones place has a 6. So I know that 2 times another number will get me 36. Well, 2 times 18 gets me 36. So we branch off here. We have the 2, which I'm going to circle again because it's prime. And I'm not going to worry, they bring it down, but I'm just going to say don't even worry about that. Just circle it when you get to your prime number. And then the other branch leads to the other factor, which is 18. 18's even, so we know it's not prime. The only even prime would be 2. So we're going to branch out again. Well, 2 times 9 gets me 18. Circle my 2. I'm not going to worry about bringing it down. And I have 9 is my other factor. I have to keep going because 9 is not a prime number. And you have that list that I gave you above or in the very beginning, so check with that. But we know that we can get 9 by multiplying 1 times 9 or 3 times 3, so that's what we have here. We don't want to do 1 times 9 because that would defeat the whole purpose. We're looking for prime numbers if possible. So 3 times 3 gets me 9, and both of these numbers are prime, so I'm going to circle them, and I'm done with my tree. Now, write the prime factorization. Well, here's one example. I have 2, my first 2, times my second 2, times my third 2, right here, and then the last two 3's times 3 times 3. If I actually plug this in a calculator or do this in my head, I would get 72. So I can get 72, this composite number, by the product of its prime factors, which is these prime factors right here. Or I could also write the same thing as 2 to the third power, because I have 2 times itself 3 times 3 to the second power, because I have 2 3's being multiplied together. Okay, this is one way. You could pick, we started with 2 times 36, but you don't have to start with a particular number. So they give you another example over here. And in this one, it just says to find the prime factorization of 72, just begin with any two factors of 72. You don't have to begin with the smallest number. So they start with, here's 72 here at the top, and they split it off here into 6 times 12, because 6 times 12 is 72. Now, neither of those numbers are composite, so you have to keep going, branch off of each of them. Well, we know that 2 times 3 will give me 6. So I've already stopped here. I've got prime number times prime number. Don't worry about writing the rest of it down. Circle your prime numbers and stop. And then we're over here on this side. We have to finish with 12 and look for factors of 12. Well, 3 times 4 will give me 12. 3 is prime. Circle it. And I have 4. 4 is not a prime number, so keep going. 2 times 2 gets me 4. Circle these last numbers, and let's see what we have here. We want to write out the prime factorization of 72. Well, what do you know? Same thing. It doesn't matter how we get it. We're still going to get 2 times 2 times 2 times 3 times 3, or 2 to the third power times 3 to the second power. Okay, let's look at the guided practice on page 124. I'm going to do the first few, or two anyway, with you, but I want you to try it, so pause me. For example, number 1 is 18. Okay, so you need to start your factor tree, and pause me, and then check and see. It doesn't matter if we start with the same factors, but pause me to make sure you get the right prime factorization, and if not, see where your mistake is, and then push play. Okay, so I'm going to go ahead and go. 18, I'm looking for two factors, and I'm going to think of, again, 2 times what? Because 18 is even, and I know times 9 will get me 18. So I'm going to circle my 2 because it's a prime number, and I'm going to branch off of 9. What times what would get me 9? 3 times 3 will get me 9, so I'll circle those because I know 3 is prime. So I would write the prime factorization of 18. My answer would be 2 times 3 times 3, or 2 times 3 to the second power. Both of those would be the prime factorization of 18. Okay, number 2, guess what? You don't have to do any work. You don't have your little handout I'm going to give you tomorrow with all the prime numbers, and I didn't tell you this, but 23 is prime, so there is no factor tree here. It's just 1 times 23 is the only way to get 23. So, looking at number 3. Number 3 is the number 32. Pause me again. Do your tree and see if you can figure out the prime factorization of the number 32. And I'm going to go ahead and start. So I'm going to look at, I know 32 is even because it has a 2 in the ones place. I'm going to look at 2 times 16 because I know half of 32 is 16. So 2 times 16 will give me 32. 2 is prime. So I'm going to circle it and stop on that and branch off of 16. Well, I can get 16 by multiplying 2 times 8. 2 is prime, so I'm going to circle it. I'm going to branch off of 8, and I'm going to say, well, 2 times 4 will give me 8. Again, 2 is prime, so I'm going to circle it. And I can get 4 by multiplying 2 times 2. So I'm going to circle it, and I'm done with my factor tree. Oops. So I have to write prime factorization of 32. So I'm going to write that would be by multiplying, how many 2's do I have here? 1, 2, 3, 4, 5. I'm going to multiply 2 to itself. 2 times 2 times 2, 5 times. I have 5 2's there. Or I would say 2 to the 5th power, which is a lot easier to write. Alright, so there are your examples. I want you to go ahead and do the rest of the guided practice, numbers 4 through 8. Number 4 is 45. Number 5 is 89, but guess what? Don't worry about it because it's prime. I don't want to send you on a wild goose chase till you get your prime number list. So don't worry about number 5. You're done with that one. Number 6, prime factorization, do a factor tree for 169. Think about those divisibility rules that you learned in the previous chapter. That'll give you your first couple of factors on these bigger numbers, right? Number 7, 216. May have to do a little math. And number 8, 243. Again, use your divisibility rules to get started with your first couple of factors. So I should see you tomorrow with these factor trees and the prime factorizations for these 4 numbers. And don't forget to come to class with a question. See you then.